Hello and welcome to the Cyber1 YouTube channel. My name is Ray, and in this video we're going to start installing and setting up the OpenPNP software for the Microsmt pick and place machine. So I've gone ahead and downloaded the software and put it on a USB stick, and it's the OpenPNP Windows x64 main that I'm using here. I'm installing this on a reasonably fresh install of Windows 10. The reason I'm using Windows 10 instead of Windows 11 is this particular machine does not have the Trusted Platform module or TPM module that Windows 11 requires. So let's start the install process. Okay, so after it's depacked or unpacked itself, we go through the setup process. So we just click on next here. I am installing this on C drive. I've got plenty of room to do it. And I will create the start menu folder, OpenPNP. Check for updates weekly. And finish our setup. Okay, so the base install itself has been done. Let's now launch OpenPNP. So if we go to Start, recently added, we have OpenPNP, so we'll click on that. I don't need this anymore. And welcome to OpenPNP 2.2. All right, let's go OK. And we have a base install of OpenPNP. Now, just to make life easy for myself, down on the taskbar here, I'm going to right click and I'm going to pin to the taskbar to make it easier to launch in the future. This PC is dedicated to the pick and place machine. Expand this out fully, and we're going to go to Machine Setup and Drivers. Okay, so once we've selected drivers, we need to move up here to the plus and click on the plus symbol and select G-code async driver. Once we've selected that, click on accept. And that creates our new async driver. We're going to rename this though to PNP board 1.7. It will be a serial. We don't need to keep alive. Line feedings need to be on. And here we need to select, in my case, it's COM3. Now I have got my Mega 2560 plugged in, but at this stage of our setup, we don't actually need it connected, which will make finding this a lot easier. This is a fresh machine, or relatively fresh machine. We will be using 115-200 board. No parity, 8 bits, one-stop bits, and we are going to turn on the RTS-CTS flow control. Now, once you've finished everything on our page, click on Apply. Very important that we do that, or we will not save our settings and we'll lose them. So under Driver Settings, we're going to go for Simulated Third Order Control. Command Timeout. The default is 20 seconds. I'm going to drop that down to 10 seconds because 20 seconds is a very long time to wait. Connection wait out, we're going to leave it 3 seconds. Maximum feed rate. Now at the moment that's set at 1000 millimeters a minute, and I think that's a little bit on the low side. So let's set that to 200,000 millimeters per minute. 50 millisecond timeout sounds good. Letter variables we will use. We will compress the G-code, and the default string here, square bracket open, square bracket close, and quote, we will leave. Remove comments because we don't need those going through to the controller. Just takes up time. And I am going to log the G-code. It's not required, and in the list that I've created of instructions, it's not there. and detect firmware will hopefully work now. And here we go. So that's all cool, and we will apply that. The OK and the coordinates that it's currently at. That won't be accurate, or it might be accurate actually looking at that. Just so you know, this is my machine. I have another camera set up looking at it, and that is in the home position where it is. I haven't enabled the machine, so we'll just move that off the home area, just so we can see it home later. And I'll turn that camera off because it does slow things down. Alright, so over in G-code, under default, and that's all we've got at the moment because we haven't set anything else up that will use it, we have command confirmed regex. And this is basically the return signal. This one, OK.star, and apply that because you may lose it going to another setting. We're going to move on to position report, and this is a long string. You'll find it will be in amongst the documentation I save. There will be a copy of this in the video on Patron. In fact, the whole instructions will be on Patron by the time you see this. Connect command is the next thing we need to worry about, and there's 3 commands involved there. We've got G21, G90, and M82. Now I haven't actually looked up to find out what they do, but when I do, I'll add it to the documentation as comments on these. You can still copy and paste that whole row if you need to. Okay, so the disable command down here, we've got quite a few to copy into there. M84, M801, M803, M805, M807 and M809. We'll apply those. For the home command, we've got 3 lines. Now I have got comments I've put onto these as to what each of the lines do. G0 is actually a move command, and Z0 is the axis we're wanting to move, and it's to the 0 position. G28 homes all axes. You can actually specify which axis is to home, but in this case it's all axes. G0, X0 and Y0 tells it to make sure you home X and Y once we're finished doing that. And again, apply. And I don't think I did that on a couple of the others. Oh, I must have. Right, so we're not using that one. Set global offsets. So just something to be aware of, and I got caught out with this. There is a scroll bar on the side here to gain access to a lot more settings. And we do need to get to this one, set global offsets. I had all sorts of trouble when I didn't realize that one didn't exist. So this is just reporting or sending the commands for the different settings we're going to be using. Okay, get position command. This is the one that beat me a lot. M114. We will apply that. And the move to command. Now this is got accelerations and the like involved in it. There is actually a scripting language used here. I'm not up with the scripting language yet. I've just learned enough to get this working. Alright, so that's basically the driver itself set up for them as far as we can for the moment. There is an actuator for the camera light, so the bottom up facing camera. So let's go to actuators, and there is a reference one here, but I want to show from scratch. So we're going to make a reference actuator, accept that, click on here, and we're going to set it to use the PNP board 1.7, and in this case we're going to call it the bottom cam lights. Wait for standstill. Now in the version 2.2, this is just a tick box. Here we've got options and we're going to go with wait for standstill. We're going to leave this as none. Again, you've got a drop down. It would be unticked on version 2.2, and on 2.4 it's before read is wait for standstill or still stand. The value type we're using is Boolean. Assume unknown, leave as is, and in this case the index will be 2, and then we apply that. This gives us the ability when we set up the bottom camera to actually turn on the light. But before that will work, we need to come down here, go to the now present actuator no head bottom cam lights. The only one we need to worry about is actuate Boolean command, and that one I'll copy and paste this one in, but it's a state-based thing, so true 804, false 805. So if we're turning it on, we send an M804. If we're turning it off, we send an M805, and apply that. Okay, so next thing we need to worry about is our axes. So let's get up to the x-axis. It's already predefined, but it's using a null driver. That's the null driver that's shown under drivers at the moment. That's not going to do anything for us, so let's set that to PNP board 1.7 and set that to the x-axis. Home coins will be 0, and steps per millimeter here will be 82. Alright, soft load limit, minus 100.000. We'll leave these safe zones as is, and we'll set the soft high limit as 405. Actually, make that 406.000. And we're going to tick that. We don't want it traveling past the end because it will crash. The feed rate will be 800 millimeters a second. The acceleration will be 4,000. And 15,000 with our jerk. And then apply that. We need to do something similar for our Y. So again, set PNP board 1.7. This will be a capital Y is the letter we're using. Again, we're going to set this to 82.000 steps per millimeter. Set this one to minus 100.000, and this one we're setting to 500, and we'll tick that again. The feed rate we're going to set to 8,000 again, 800, sorry. Acceleration will be 4,000. And 15,000 for the jerk. And we'll save that. This one, we're not going to make any changes here. It's the way it's been defined in every version I've seen where it's been working, so I'm going to leave it alone. Reference virtual rotation axis top. I'm going to leave as is. Actually, yeah, that's virtual axis. Reference controller axis N1. Now I'm going to change that to just Z1. So essentially we have one Z axis, but because it moves one head up and one head down at the same time on the same rotation, I'm going to call one Z1, one Z2, but Z2 will be a virtual mapped one. So this will be Z on the PNP board 1.1. It's still a linear movement, and this one is a little bit different. At 168. Okay, so soft load limit. This is an interesting one. So our Z-axis actually works in the negative range, and I'm allowing it to go down 35 millimeters. In the default setup, it goes 25, but I found it doesn't reach the parts or the boards when you're doing it to 25. If you allow for a minus 35, you'll get down to the boards and the parts. So that needs to be ticked. These two we can untick. We will tick that one, and this one will be 35.000. As for our movement, 20,000 looks right. This one we want to make 3,000. And we're not going to bother with a jerk on this. We're going to set it at 0 and apply that. We're going to also add a mapped axis. So reference mapped axis, accept. Click on that. It's going to be a Z-axis. We're going to call it Z2. Input axis is Z1. Input will be 0 to 1 for A, so point A to point B, 0 and 1. Output will be 0 to -1. And then we'll apply that. So it actually works in the opposite direction of the Z1. Right, let's go back to our rotational axis N1. Set that to use our PNP board. The drive letter for that will be A. And we do turn this on. So we're doing a rotation. The resolution here that looks right actually. Minus 180.000, and we will turn that on, and positive 180, and again we'll turn that on. Alright, so our feed rate is 20,000. This one here is 10,000. So this one's our acceleration. And we'll leave the jerk turned off and apply that. But as you know, we have two nozzles on our system, and the second nozzle needs to be set up as well. So we're going to click on plus, create another controller axis, accept, click on a new one. This will be a rotation type, and this one will be N2, rotation. The driver will be the pick and place board, and this will be B. minus 180.000 for the soft low limit, 180.000 for the high limit, feed rate 200,000. It needs to be 10 and 2,000. And we set the jerk to 0. And apply that. Now, because we've specified our N2, we do need to tell the system about it in the heads. So we do have a reference head. By default, it comes up as homing method is none. And when we go through the calibration, we're going to change that at that time. So we'll leave that as is. At the moment, we have one nozzle, reference nozzle, which is N1, and it's using rotation 1 and Z1 over here, as well as the X and Y. But because we don't have an N2, it will throw an error if we try and start up. So let's add another nozzle. It'll be a reference nozzle. And here we're going to call it N2. We're going to select the X-axis, the Y-axis, and the Z2 axis, as well as rotational N2. And everything else looks all right for now. There are a heap of other settings we've still got to set up. That'll come in under calibration. There is a camera, and we will play with the camera as well. And under actuators, we have got the top light, the pump, and A1, which we will set up as well in the next video. So let's see if we can get this to work. So we're going to go File, Save Configuration. So we save the current configuration and turn it on. And we've got a control panel has come up. So if you have a look in here, you can see where the camera, the head is at the moment. So we're going to click on Home, and you can see it now homing. And we've completed our homing. So that's the end of this video. In the next video, we're going to look at the calibration of the X and Y axes using the fiducials. So before we do that, we need to set up the camera. So I'm going to do that in the next video. To see when that video comes out, don't forget to click on like, subscribe, ring that notification bell. It's a form of support that helps the channel a great deal and costs you absolutely nothing. If you'd like to support the channel further, I do have both YouTube membership and Patreon, and you can join my VIP patrons GoLucky, Jeff Jerde, Keres Contorni, my builder patrons Al Morales45, Andrew Cardone, and Edgar69, and my new YouTube member Joel Hauxwell, in helping to support the channel. All my members get these videos at least a week early. If you've got any questions, feel free to leave a comment below or drop into the Discord. There will be links in the description for not only my Discord, but also the official Pick and Place Discord, Microsmt Discord, the PNP headquarters Discord as well. Both of those are very good resources for information on the Pick and Place machines. And we'll see you in the next video.